All right, so what we're doing so far with exceptions is that we have, we have handled an exception, and we have sort of recovered from it. Actually, we're not doing anything, but I did show you how we could recover from an exception. We if it's if it's not okay, then we will loop and have another input value, and I mean, as you can see, we when everything is okay, this line will be called, and we will return from the function. But I mean, of course, there are different type of errors. We will need to recover from it in different ways. Of course, I mean, if there is a out of memory, it would be one type of recovering, if any. I mean, out of memory, that's not so easy to recover from. But I mean, it really depends on what the error is. We need to handle different type of errors, different type of exceptions. And let me start by showing you the built-in standard library exceptions. So as you can see, there it there it disappeared. So we have basically we have two kind of errors, and all this is, I mean, it's built up using inheritance and so what you can see here, an exception is a class, and we have I mean, logic errors, and we have runtime errors. Logic errors could be like, okay, invalid arguments. So if we send an invalid argument into a function, or that could be like a domain error, and I'm not sure what that means. Length out of range, yeah. There are also other types of errors like range errors, which I'm not sure how that differs from that one. Never mind. Overflow, underflow, I mean, there are a lot of different type of errors that could happen. Bad alloc, I mean, there's out of memory and so on. So, I mean, that's how we are able to act differently depending on the exception, the problem. Let's have a look. I will just okay, because what we are able to do is we could handle multiple types of error in the same try block, or what I should say. Okay, so this is a kind of typical kind of error I'm showing you here. Actually, I could do anything. Okay, let's do like this. So whenever an out of range error happens, this will be called. And whenever let's do I have no idea when this would happen, but let's say bad alloc error. When there is a bad alloc error, we could say like, oh, it's toast. We're totally screwed, and we might exit the program or something. I don't know. So I mean, the thing is, depending on the type of error, I mean, when we do call inside a try block, multiple things could of course happen because we have multiple calls. There are multiple things happening here. So I mean, it's not like out of range exception. Anything could happen actually. We could also and we typically do in the end of this change chain of exception handlers, we have a general, like, okay, so exceptions are, and I will show you the precedence order and the difference. I will just in a minute. So this could actually be like, okay, there was some error we don't know about. So this will catch pretty much anything. So let's, when we run this, if there is an error of type bad allocation, I mean, it could happen here actually. Now it's pretty hard to force that error to happen. I have like 16 gig of RAM. Not like, I have 16 gig of RAM, so it won't happen. We have to wait for a while for it to happen, like in a loop. But anyway, if that happens, we will end up in this line, and we could try to recover from it. That's the main how you should look at exceptions. Something bad happens and we should try to recover from it, maybe, or we could decide we can't recover from it. Anyway, if there's some other type of error, as you can see, there are lots of type of errors that could happen, like length error, bad, weak, pointer error. Anyway, I don't know, like half of them, when to use them and so on. Since, let's say, an overflow error, right? An overflow error is a runtime error. A runtime error is an exception. So I mean, all these classes inherit from stud exception. And since it derives from exception, I mean, all exception that happens will be of type exception. Even an out of range exception inherits from exception. So therefore, it's important, the order of your catch handlers are important. Let's do like this. What will happen now is when we get into function C, there will be an out of range exception, and then this handler will be called, not this one. Because it will look from the top to the bottom and see, okay, this exception that happened, it's an out of range exception. Does it match this catch handler? Yes, it does, because an out of range is a exception. So it derives from exception. So order matters, like this. Okay. Let's have a look what else we should talk about. I think that was pretty much it. Okay, so all exceptions have a .what function. It's a virtual function, and all exception classes override it. We will talk about it later when we talk about OOP and virtual functions and polymorphism and so on. But I mean, this will mean that an out of range error will when this function what is called, it's not the same function as when what is called for the bad alloc. So it's overriding and specializing functions. Okay. Anyway, let's have a look at yeah. Actually, the thing is, how can we use exceptions? Can we throw exceptions? Yes, we can. I mean, we could throw exceptions. Yeah, we could. We could also, and I will come back to that. The thing is, we could throw pretty much anything. So an exception doesn't have to derive from that exception class. So let's have a look at that. Throw 12. I mean, that's so weird, but it's possible. This is okay, C++ code. It is okay to throw anything. It could be a value of any data type. It could be an object. It really could be just anything, and this will be, I mean, this won't be catched by any of these, because the integer 12 is not it's not derived from exception. But I mean, we could, and this is so weird. I mean, I just want to show you this quickly, and then I will remove it. I mean, it is possible. You will see it. This is okay. And when we throw an integer, this handler will be called. Yeah. I mean, okay. So it's not possible to call .what, of course, but like this. It is possible. It's not recommended. It's recommended we always use the built-in. We always throw, and I will show you. We could throw an invalid argument, and it should say like, okay, an error occurred. This is weird. I mean, it's not even taking an argument. But I mean, I'll just show you the syntax. We are throwing an exception. Yeah. Actually, we're throwing a real exception. So it's I mean, it's derived from the exception class. Anyway, that's how we could use exceptions. Let's just I will just finish this up by saying, I mean, exceptions are, as I said, controversial. And carefully, listen to me carefully. Some says, I'm not saying, especially not in this course. I'm not saying anything. I'm not. I mean, exceptions. I will soon say exceptions are good. But anyway, there are languages like Go. Go is a pretty new language, which doesn't even have exceptions. I mean, it's a modern language, and when they designed the language, they decided we won't use exceptions because they are bad. Actually, exceptions, they don't say exceptions are bad, but they are misused by programmers so much, so it's better to not have them. Actually, Google, which created Go, thinks the same about their C++ internal programmers. This is the guide for the CPP guide for employees at Google. So when they use C++, they say we do not use C++ exceptions. Actually, even in the standard for C++, OpenStud, they are saying, I mean, there is a paper stating that C++ exceptions are becoming more and more problematic. And what they are saying is that, especially, I mean, the way exceptions are implemented in the standard library is, I mean, there has to be a global area. Actually, I'm thinking, yeah, global mutex to protect the binding tables from concurrent changes from shared libraries. Yeah. So I mean, there is a shared resource which will lead to really bad performance when we are using multiple cores and multiple CPUs. So I mean, here we have 128 threads. Yeah, 128 cores, and performance because of that shared state. There are locks, and there are problems which are becoming a fact now when we have more and more cores. Okay, so it's but I mean, exceptions can be faster as well. It's I mean, it's a fact. Hear me out. It's a fact that exceptions do cost. Well, especially when there is an exception is thrown, there is a cost. No doubt about that. So I mean, this stack unwinding and everything, and looking up and down and everything, there is a cost. On the other hand, let's have a look at this one. So we have a try and catch. When there is no exception being thrown, this code will have very little overhead. Very little overhead. So we call change, and so on. And we have a catch. So in the happy case, when there are no problems, this code is I mean, there is a little overhead by setting up the exceptions, try block. But let's have a look at this one instead. Let's do this without try and catch. How would that look like? All right. So we have, yeah, here it is. So first we call change with value 1, and we do return, and I mean, have a look at the change function. So we return an error code instead. Here we okay, so actually we're not returning anything. So I mean, a return will also cost, and we also, I mean, have a look at that. So we call change, and we check for error, and we call change, and we check for error, and we call change this third time, and we check for errors. I mean, this has to be done for each and every call. We need to check the error code. Here we just call the function. We never look at the return value, we never have any ifs and buts, but we just go on to the next one and the next one, and if anything goes wrong, then this will be called. So as you can see, exceptions doesn't have to be that bad. If someone says it's bad, I don't think, I mean, yeah, but I mean, there could even be performance, I mean, positive performance from using exceptions. Okay, so this is in Swedish. It's also one of the things on the one of the hot things right now is trying to minimize or eliminate branches. So a modern CPU, I mean, it's extremely fast when all the instructions are, I mean, just okay. So it's taking one instruction at a time, but I mean, programming, that's a pure sequential program. But which might sound like that's not so useful. We need to do ifs and so on. But an if, that will mean that maybe after an if, we have to jump somewhere. We have to do a branch. We have to jump to another instruction which might not be the next one in line, and that's a performance penalty. So I mean, go into branchless programming. That you can Google it. I mean, it's a fact, and this is branchless, right? So I mean, if there are no if statements, so it could be better performance from that reason also. And I think this code is more readable. I think you agree on that. This is more readable than this code. I mean, it's really hurting my eyes. Anyway, so that's. I mean, there are pros and cons, like with everything, and I think you will have to. I mean, should you use exceptions or not? It's like anything else. It depends. But probably you should. I don't think the negative sides are that important. There are positive sides, as I said, that are equally important, if not more. Okay, so that's all about exceptions.